Have you ever wondered what it takes to construct a tunnel that stretches wider than a 5-story building, runs under one of Earth's most unpredictable rivers, and gets built in just 110 days? Sounds like something from a science fiction movie, right? But this remarkable feat of engineering was pulled off by China's team of engineers, who made the unimaginable a reality with the Jinan Huang Road Tunnel. If you thought building underwater tunnels was an impossibly slow and risky business, you're not wrong, until now. So how did they do it? Let's break it down. The need for the tunnel. Jinan, the capital of Shandong province, earned the unfortunate title of China's most congested city for 2 consecutive years. That's right, Jinan, a city of 9.4 million people, faced traffic jams that cost the economy more than $2.3 billion annually. Drivers spent countless hours sitting idle in their cars, wasting fuel and losing productivity. The bottleneck? The mighty Yellow River Dot. For decades, the people of Jinan had only 2 primary options for crossing this unpredictable river: crowded ferries or traffic-laden bridges. Neither solution was ideal. Ferries were slow, unreliable, and simply couldn't handle the volume of commuters. Bridges, while better, faced regular congestion, with some stretches snarled in traffic jams stretching over 4 miles long. Imagine turning a 10-minute crossing into a 90-minute ordeal. The time for a solution was overdue. The city needed something more efficient. The answer? A massive tunnel that would sit underneath the Yellow River, bypassing all the traffic headaches and providing a much faster connection between the city's northern and southern districts. Why not just build more bridges? That was the initial thought, but building more bridges across the Yellow River wasn't a simple fix. The geography of the river made it nearly impossible. With shifting banks, sensitive ecological zones, and a lack of stable crossing points, constructing additional bridges would have meant demolishing entire neighborhoods, displacing hundreds of thousands of people. So engineers faced a tough decision: risk sinking a bridge into the soft silt of the riverbed, or dive beneath it and build a tunnel dot. Choosing the latter, the construction began in September 2024 with the goal to build the world's largest underwater tunnel. This ambitious tunnel would span 5.4 kilometers, 3.3 miles, with 3.6 kilometers, 2.2 miles, running beneath the riverbed at a depth of 150 feet. The tunnel would handle around 30,000 vehicles daily, roughly equivalent to adding 6 new bridges worth of traffic capacity. But how could they achieve this in such a short amount of time? Let's look at the engineering marvels that made it possible. Engineering feats. The design of the tunnel had to be both practical and innovative. Engineers opted for a double-decker structure, which maximized the tunnel's capacity without requiring it to be wider. The upper deck would handle 3 lanes of southbound traffic, while the lower deck would carry the northbound lanes. This design allows 30,000 vehicles to travel through the tunnel each day, solving the traffic woes of millions. But building an underwater tunnel isn't all about just fitting lanes for traffic. Safety was a critical consideration. The tunnel boasts 27 emergency exits, spaced every 200 meters, leading to elevated walkways above potential flood levels. These are essential for ensuring the safety of drivers and workers alike in case of an emergency. As if that wasn't enough, the tunnel also has 16 jet fans per kilometer that ensure proper ventilation, replacing air every 3 minutes. The walls themselves are 1.2 meters thick, capable of withstanding water pressure equivalent to 40 adult elephants pressing against every square meter. Construction at lightning speed? The real kicker is the speed at which the tunnel was completed. Most projects of this scale would take years, but China's engineers reduced the timeline to a mere 110 days. This accomplishment was possible due to several key factors, starting with prefabricating 92% of the tunnel components off-site. This strategy drastically reduced the amount of material storage needed on-site by 80%, allowing for more efficient construction. They used a just-in-time delivery system, ensuring the components arrived exactly when needed. With this approach, engineers could maintain a constant pace without any delays. It also allowed the team to recycle 98% of the excavated material, which was put to use in nearby road projects, reducing waste and environmental impact. But what about the riverbed itself? The Yellow River's shifting soil, composed of a mixture of sand, silt, and shifting water pressure, presented a unique challenge. How could they dig through something that's essentially quicksand? The tunnel boring machine, The solution came in the form of the Shanghai Tunnel Boring Machine, TBM. This colossal machine weighs 4,200 tons, which is roughly the weight of 10 fully loaded Boeing 747 airplanes. But its size alone didn't make it special. What set Shanghai apart was its ability to handle extreme underwater pressures and geological conditions. Powered by a cutter head that generated 7,500 horsepower, Shanghai was capable of cutting through rocks, clay, sand, and silt with ease. It advanced an astonishing 16 to 18 meters, 52 to 59 feet per day, significantly faster than most other tunnel boring machines currently in operation. But the real magic was in its adaptability. Over 3,800 sensors monitored the tunnel boring machine in real time, measuring everything from groundwater pressure to metal fatigue in the machine's cutter teeth. When Shanghai encountered an unexpected granite layer beneath the riverbed, its AI system recalculated the pressure settings in just 8 seconds, something that would take human engineers 45 minutes to do manually. And let's not forget the machine's protective shell. As it dug through the riverbed, Shanghai laid down 72-ton concrete rings every 2 meters. These rings were locked into place with millimeter precision to prevent the tunnel from collapsing into the shifting riverbed. It was like performing delicate surgery with a 200-ton robot. Facing environmental challenges. While speed and innovation were key, the engineers also had to make sure the project didn't harm the Yellow River's delicate ecosystem. The tunnel's construction disturbed only 15% of the riverbed habitat, and sediment filters helped to treat 6,000 cubic meters of material daily. These filters recycled 98% of the excavated material for reuse, ensuring minimal waste. Additionally, the TBM slurry system filtered out 98.7% of particles above 0.1 millimeters, preventing contamination of the river's waters. To protect aquatic life, noise levels during construction stayed below 75 decibels, quieter than a blender. In addition, crews installed 8 miles of silk curtains to trap sediment, preventing it from polluting the river. The environmental safeguards didn't just stop at filtration. They also used thermal sensors to monitor lubricant temperatures, ensuring that no heat damage affected the delicate aquatic ecosystem. With such careful planning, the construction team managed to balance rapid progress with eco-friendly practices, breaking records and setting new benchmarks. The Jinan Huang Road Tunnel holds several significant records. Not only is it the world's largest underwater tunnel, but it also boasts the widest diameter at 17.5 meters. To put that into perspective, that's wider than the Channel Tunnel and Norway's Rogfast Tunnel. It could even fit 2 subway trains side by side within its walls. And while it's not the longest tunnel, its speed of construction sets a new standard for large-scale engineering projects. The project cost a fraction of what similar tunnels in other countries would have, with estimates placing it at $95 million. By contrast, Norway's Rogfast Tunnel is projected to cost $2.1 billion for just 16 miles. It's clear that China's rapid construction techniques are paying off in terms of cost effectiveness. Can China build even bigger tunnels? So, what's next for China's ambitious infrastructure plans? The country has already begun planning a $45 billion, 76-mile undersea tunnel across the Bohai Strait. Engineers are eyeing a 12-year timeline for this project, but after witnessing the incredible speed of the Jinan Huang Tunnel, we can't help but wonder, could they do it faster? Only time will tell. In the meantime, the Jinan Huang Road Tunnel stands as a testament to human ingenuity, pushing both machines and workers to their limits. If anything, this underwater tunnel proves that when it comes to infrastructure, China isn't just breaking records, they're rewriting the rulebook on what's possible. And that's a wrap on this incredible engineering feat. If you're amazed by China's underwater tunnel, hit that like, and don't forget to subscribe for more mind-blowing stories, and leave us a comment with your thoughts on this record-breaking project. We want to hear from you. Until next time, keep your curiosity flowing and your imagination diving deep.